Good morning, Year 5. Today we're going to continue your work with area, but we're actually going to include perimeter in that as well. Before we do that, if you haven't yet watched the fluency video, could you stop this video and go back and watch the fluency video first? Because I would always suggest you watch those first as a warm-up. Okay, so the learning target today is to solve problems with area, but as I say, that will include perimeter as well. So it's really important that we remember the difference between the two. So remind me with the actions, perimeter is the walk around the outside of the shape. So it's the distance around the outside, and it's just measured in units, whether that's centimeters, millimeters, meters, kilometers, it's just the unit itself. And then area is the space shape takes up. And I want you to imagine that as if you were colouring in a rectangle, it would be what you've coloured. The space you've coloured is the area. And we measure that in units squared because it's like you're putting little squares on top. So you would have rows of squares and columns of squares, just an array. And so we measure it in units squared, which is that little 2 at the top after the unit. Okay, so just some quick questions to warm us up here. A shape has a side measuring 6 meters and 11 meters. What is the area of the shape? The area. Okay, so just think about this for a second. What have you got to do to find the area? You've got 3 options there. Area, remember, is the width times the height, because you're finding, like that array, you're finding how many squares you've got in each row and each column. So you're timesing this by this. So we've got 11 and 6. So tell me the calculation and the answer. Hopefully you got 66. It was 6 times 11, and it's 66 meters squared. Must be squared. Let's have a look at the next one. A shape has the sides measuring 6 meters and 11 meters, exactly the same as last time. This is odd. But what is the perimeter of the shape? So this time we want the perimeter. Now don't forget, we don't just want 2 sides. We want all 4 sides. So how would you work out all 4 sides? So we've got 2 lots of 11 and 2 lots of 6. So you could do 6 add 6, add 11, add 11. You could do 6 times 2, add 11 times 2. Or you could do 6 add 11 and times that by 2. Let's think about it. I'm going to do 11 times 2, which is 22. I'm using my mouse again, which is why this isn't very good. I forgot to plug my pen in. And then 6 times 2 is 12. And then we add those together. Oh my goodness, this really is awful. Okay, 6 times 2 is 12, and then to add those together, we've got 20 and 10, which equals 30. 2 and 2 is 4. So I think it's 34 meters. And because we're measuring the perimeter, it's a distance. It's not squares, it's a distance, which is why our 34 meters hasn't got the squared symbol. Okay, the next question. The area of the shape below is 32 meters. What is the missing length? So for area, remember we times the width by the height. So what we've got here is the answer already. We know that our answer is 32, and that's meters squared. So we know one of our numbers that we're multiplying is 4, but we don't know what the other one is. So I've got to use my knowledge of times tables to work out what I times by 4 to get to 32. In other words, what's the factor pair that goes with 4 to make my product of 32? 32 is the multiple. I need to find the other product that goes with 4. So think about your factor bug. You've got 1 and 32, and then you'd have 2 and 16. What would go with 4? Hopefully you've worked out that it's 4 times 8, but we've got 2 options here. Is it 8 meters or 8 meters squared? Which one do you think? Well, because we're just finding a distance, we're not finding an area, we're just finding a length, it would be simply 8 meters. There it is. I hope you got that one. And here's the next question. What is the area of this composite shape? And a composite shape just means 2 shapes have been joined together. So we need to work out the area of the blue rectangle, then work out the area of the orange rectangle, and then what have we got to do? We've got to add them both together. Okay, so let's think about the area of the blue. So we're looking at area here. What do I do to find the area of that blue rectangle? I'm going to multiply them. So I do 4 times 9. And 4 times 9 is, have a think about it if you're not sure, it's 36. And that will be centimetres squared. That should go straight after 36, but I've run out of room. Now, so I can already know it's not that one because I need to find the area of both shapes added together, and 36 is only the area of one. And also I think I can get rid of this one because that's smaller than 36. So I don't think it can be that one either, but I do want to check. So now I need to find the area of the orange shape. So what do I do to find the area of the orange shape? I'm going to do 6 times 5. And that one you should be able to work out quite easily is 30. And that would be centimetres squared. So now to find the area of both of the whole shape, I just need to add them together. 30 and 30 is 60. Add the 6 is 66. So I think it's that one. And we've got the right unit, centimetres squared. Let's check. Yes. Okay. What I'd like you to do now is read the vocabulary here on the left-hand side, and I want you to see if you can, just with your finger on the screen, match the word with its definition. Now the word boundary might be new for you, so see if you can work that one out, maybe process of elimination, because all the other words we've looked at. So I want you to pause the video now and just with your finger match the word to the definition. Okay, let's have a look at each word in turn. So the first word was area, and that's the space on the inside of the shape. It's surface, the surface of that shape. And as I said earlier, if I ask you to colour in a rectangle, it's the space you've coloured in. That's the area. It's the amount of space it takes up. Boundary. Now that was a tricky one because it wasn't one we've looked at before. Let's see if you got it. The boundary is the lines on the shape that mark the perimeter. So it's the outside edge, like the boundary of a field, or you could say this is the boundary of my land, my property. So it's the outside edge. It's the farthest point it can go. The perimeter is that measurement all the way around the shape. And of course the shape doesn't have to be a rectangle. You could have a perimeter of a triangle. You could have a perimeter of a composite shape, which is a rectilinear shape maybe where they've all been joined together. You could have perimeters of any sort of shape. Rectilinear shape, that's the shape that's made up of rectangles. Do you remember? Like that composite shape we looked at before. So it's a shape that's made up of rectangles. In other words, it's only got right angles. If it's made up of rectangles, it must only have right angles. So no other angles, internal angles, apart from right angles. And the last one I hope you got, the quadrilateral, which is a shape with 4 sides. And that could be regular or irregular. Okay, just as a little quick activity on a piece of paper or on your whiteboard, I would like you to pause and see if you can remember how to draw the factor bug for the number 20. I've started it for you. I'd like you to finish it. Have a go. Don't worry if you can't, because I'm just about to show you. Pause now. Okay, let's have a look and see what it should look like. So here is the factor bug of 20 with the factor pairs shown. So we always start with 1 and 20 and then 10i, and then we work round in order. So after 1 comes 2. 2 is a factor of 20 and its pair is 10. 2 times 10. 3, no, 3 is not a factor of 20, but 4 is, and its factor pair is 5. And then I know I'm finished because I've caught up with myself and I've got round to the other side. So I know I've finished. Do you remember these? Okay, so there was a reason you did that, and you'll need to have that factor bug in front of you now. So if you didn't write it down, quickly write it down now, because you're going to need that now. What I'd like you to do now is to try and draw shapes with the same area, and that area is 20 centimetres squared. So I would like you to have a go at drawing rectangles that have an area of 20 centimetres. Use those factors on that bug to help you. And here I've given you one example. I'd like you to see if you can think of any more. Use those factors and their pairs. That's really important. So just to give you a clue, you might have noticed I've just changed location as well. Just to give you a clue, think about the factors. So we've done 1 and 20. What was the next pair? So the next pair, you might want to start with 2 centimetres and something. So think about what your next pair might be. So pause the video and have a go. See how many there are. Again, it will link to the number of factors. Pause the video and have a go. Okay, hopefully you've worked out that there were 3 different rectangles you could make, and that's because there are 3 factor pairs that make 20. So if you think back to the bug, well, we had 20 in the middle at 1 and 20, and then we went round, we had 2 next, which goes with 10, 2 times 10, 3 wasn't 1, 4 was, and that went with 5, and that means we've got back to where we started. So here, using those factor pairs, we've got 1 times 20, which gives us 20 centimetres squared, 4 times 5, which gives us 20 centimetres 5, and 2 times 10. So those are the 3 ways you can make rectangles with the area of 20. And what's really important here is to realise that the shape has changed, but the area has stayed the same. So they take up the same amount of space, but the shape itself has changed. Right, over to you again now. I want you to do exactly what we've just done, but I want your areas to have your rectangles to have an area of 24, so the amount of space. I would suggest you start by drawing the factor bug first, so you know how many rectangles you've got to find. The amount of factor pairs will tell you how many rectangles there are. So I would draw the factor bug for 24 first and then have a go. So pause the video and then resume when you've had a go. So now we have got the factor bug for 24, I want you to have a go at drawing those rectangles that have an area of 24 centimetres squared. Don't worry if they're not to scale. Okay, just label them with the correct sides. So pause the video and have a go. Okay, I'm hoping that you got the same rectangles I did by using those factors. So thinking of your factor pairs, here's 1 and its pair 24. Here is 2 and its pair 12. Here's 3 and its pair 8. Here's 4 and its pair 6. And of course there isn't a 5 because 5 is not a factor of 24. Right, This one is tricky. We are going to go through these. There are two statements here, and you need to test both of them. They're both different. So I will tell you when to pause, but let's just talk about them first. So this lady says the perimeter of a shape will always be greater than the area. And she's drawn a rectangle to prove that. So the area of this shape, she has said, is 8 centimetres, and I've cut it off there by mistake. That should be squared. So she said the area of, sorry, my pen is playing up again. She said the area is 8 centimetres squared, and the perimeter is 12 centimetres. So you can see there the perimeter is bigger than the area. Is this always true? That's statement number one. Statement number two is this young man here, and he says shapes which have the same area will also have the same perimeter. So he's saying if you draw two different shapes and they have the same area, which of course should have the 2 after it, they will also, sorry, I don't know why this happens, but it keeps turning into a mouse. It doesn't pop up on your screen, but I get a right click and it's really annoying. Let's try that again. There we go. That's better. So he has worked out that these two shapes, they're both rectilinear shapes. They both have an area of 8 centimetres squared, and they both have a perimeter of 12 centimetres squared. And he thinks that will always be the case. Okay, you've got to investigate both those statements. And the way to do that is by what is written up here. You'll need to draw some rectangles out to test this. And all you need to do is to find one rectangle maybe that doesn't follow that rule, and you have disproved it. Okay, so see if you can find just one rectangle or one rectilinear shape, in this guy's case, that doesn't follow the rule. Okay, just one, that's all you need, and you've disproved it. So you'll need to draw some rectangles out to see if you can find, in this case, an area that's bigger than a perimeter. And in this case, see if you can draw maybe another shape that's got an area of 8 but doesn't have a perimeter of 12. Okay, so pause the video. We'll go through it afterwards, but pause the video and have a go now. Right, let's look at this lady's first of all. Now, the rectangle she drew was quite small. It was just 2 times 4, which gave us that area of 8. There's the 2 going down the side, and there's the 4 going along the top. That gave us our area of 8 centimetres squared. I kept cutting those out when I was copying and pasting these pictures across. Okay. So that's quite a small rectangle. So we're going to think bigger. And I thought, well, what about if I go for one that I think, right, let's go bigger. Rather than 2 times 8, I'm going to go bigger. So I decided to have a square that was 5 centimetres by 5 centimetres. So I drew out that square, which is also a rectangle, don't forget. And I worked out my perimeter would be 5 times 5 times 5, not times, sorry, my perimeter would be 5, add 5, add 5, add 5, 4 times 5. So here I've written that out, 5 add 5 add 5 add 5, or I could say 4 times 5, and that has given me a perimeter of 20 centimetres. So we've got to see if she's right when she says that perimeter is always going to be bigger than the area. Now the area would be 5 times 5, and 5 times 5 is 25, which means our area is bigger than our perimeter. So what she has said isn't true. Do we say it's always true or never true? What word would we use? Sometimes true. That's the word I would use. She is sometimes correct when she says that the perimeter of the shape is always greater than the area. That only happens sometimes. Okay, let's look at this chap. Shapes which have the same area will also have the same perimeter. Now, think back to when I asked you to draw the factor bugs and draw the different rectangles. So we worked out that there were different ways to show the same area. Are all these shapes, so this is when we did 20 centimetres squared for the area, do they all have the same perimeter? Let's have a look at this one. The perimeter will be 20, add 20, that's 40, add 1, add 1. So that's 42 centimetres. Well, we've got to now see, and that's just the perimeter, so I'm not going to put squared because that's the perimeter, and the area of that, of course, was 20. So we've got to see now if all of these get to 42 centimetres for their perimeter. Okay, so let's look at this one down here. 5 add 5, that's 10, add 4, add 4, that's 18. Already I can see that he isn't correct because these two have different areas and perimeters. Okay, let's just check this last one. The perimeter of this one, we know the area is 20 centimetres squared. The perimeter is 10 add 10, which is 20. Add 2, that's 24. So, again, he is not correct. I've given him a sometimes too, because he's shown us one that is correct. I've shown us one that isn't. So we'll go with sometimes. Now, these are the activities I want you to have a go at. They are tricky. And there will be lots of different answers. You will all have different answers to each other for this, which is why I can't give you the answers because they're all sorts of different ones. But I'd love to see them uploaded to see how you've done. So the first question, I want you to draw a shape where the perimeter is greater than the area. Okay, think back to the two problems we've just looked at, where the perimeter is bigger, so maybe a perimeter of 24 and an area of 20 centimetres squared, something like that. Then I want one with the same area and perimeter, and then I want one where the area is greater than the perimeter. Okay, so think back to the last question we did. Then this one sounds like the one we did earlier, but it's not. Earlier, can you remember we drew rectangles that all had an area of 24 centimetres squared? This time, I want you to draw rectangles where the perimeter is 24 centimetres squared. Again, use a system. If you had two sides of 1, what would those two be? And then if you had two sides of 2, what would those two be? Then if you had two sides of 3, what would those two be? So use a system for that. This question here is just like we did with the factor bugs. Draw different rectangles with an area of 12. So first of all, find the factors of 12 and use those to work out the areas. This last one really will get you thinking. The perimeter of a rectangle is 24. What could its area be? And that word could is super important because that means there's more than one answer. Okay, if the perimeter is 24, what could its area be? You might even see if you can find more than one. Okay, so they're tricky, but have a go. Lots of experimenting, lots of drawing rectangles with what you've done. This one's going to have to be on paper. Okay, so pause now and have a go at those.